Hi, I hope that you are doing great, especially on these hard days that we are dealing with this damn coronavirus. I hope that neither you nor your beloved ones have been affected by this virus in any ways. Probably the most effective measure that one can take on these days that we have to spend a lot of hours indoors is to keep ourselves busy in one or the other way. For me, mathematics is probably the only way that I can keep myself busy for a long number of hours. Firstly, because I really enjoy this doing mathematics. On the other hand, if I want to succeed solving the problems, because usually they are hard, so I have to be fully engaged with the problem if I want to have a chance to succeed in solving the problem. So then I will not feel the passage of time as much as I could do if I was not doing mathematics. Uh, in this video, I'm going to solve the problems related to lecture 11. If you have been following my YouTube channel, probably you know that there is a playlist on my YouTube channel called Advanced High School Algebra. I will upload this video onto that playlist. Of course, this way of teaching, I'm completely new to this. I have been training this way of teaching for nearly 2 or 3 weeks now. And I've been teaching mathematics for more than 25 years, or I don't know, I think it's now close to 30 years. And all that time, except the last few weeks, I have been teaching mathematics in front of the whiteboard, or even in old days, in front of a blackboard, and I was in front of the students, interacting with them, asking questions, getting feedback from them. If they have questions, I could answer them immediately. But then this is a little bit strange sitting here alone and talking into your camera. I have to get used to that, of course. I'm definitely sure that I will get used to it, and probably I will start liking it. Even in these 3 weeks that I have started doing it, I think I really like to do it. Even though there are not a live audience in front of me right now, but there would be a lot of people probably in the future watching this video. So I can consider that all of them right now are in front of me, okay? So as I told you that in this video, I am going to solve the problems related to lecture 11, okay? That was related to factoring polynomials part 3. My pre-assumption is that if you are watching this video right now, I'm assuming that you have already watched that video that I was teaching the material necessary to solve the problems for this problem set. So what I want to do, I am actually using iPad Pro with my Apple Pencil, and I am using application GoodNotes version 5 to write on my iPad. Then I am using the Zoom application to project my iPad screen onto my iMac screen, so that when I write on my iPad, you can simultaneously see it. And then I use the Zoom application to record the video and publish it later. So below this video, you will find a link to the PDF file that contains all the problems that I am solving in this session. Then you will see another link that will give you, so let me share my screen and show what I am supposed to do. One moment, please. Yes, so this is the file that I was talking about. You will get a PDF file for this one, for this questions that you see exactly like this. So I have these questions that you see here are actually the questions chosen exactly from the problem set that I told you that you will get the link to download the PDF file of that set of questions. And then I will try to solve these problems and explain for you. Then exactly I go to the next page. These are the other problems. Then I go to the next page. These are the other problems. I will try to describe the solutions of these problems in details. As I told you, I will not repeat all the material from the previous lecture. If there is something that you don't understand, you can refer to those videos. Okay, so I will give you this file that you just see here. If you want, for example, you can print this out and start solving the problems yourself first in this space that is here for you. And of course, I can also share the GoodNotes file for you, so that if you have access to iPads and GoodNotes and Apple Pencil, you can open it in your GoodNotes on your iPad and start writing this immediately. So you don't need to print it out or something. But so that's up to you. You can actually be creative and find a way which is suitable for you. But I will provide all these possible links for you. That's so you can download it and use it as you like. And at the end, when this sheet is filled with my solutions, I will also give you the link so that you can download the PDF file containing all detailed solutions in written form. So it would be useful for your future reference if you are interested. Okay. So let us start doing this experiment now. Okay. So. So the first problem of this problem set, part A, is factorize the following polynomials. So there are 15 questions in part A. So 6 of them you can see here on this page, okay? So if I want to solve this problem, so number 1, so x squared minus 8x plus 12. So if you remember, one of the ways that I told you in the previous video, if you want to factorize this, it might happen that we are able to factorize this using this common term identity. So this will play the role of the common term if this is going to be solved using that identity. So then you will have, you open 2 pairs of brackets, put the x here and there, and then ask yourself that I need 2 numbers with sum -8 and with product +12. So here I am actually relying on your skill to guess this actually. Okay, so what are those numbers? Those numbers are not that hard to guess. One of them is -2, the other one is -8. -6. The sum of -2 and -6 is -8, and if I multiply them, it becomes +12. So that's the factorization of this polynomial. Yes? Let us go to the next one. So the next one is x to the 2 minus 22x plus 85. So what you do is that you open 2 pairs of brackets, put x here and here, and then ask yourself, I need 2 numbers with sum equal -22 and the product +85. So what are those numbers? These numbers probably are a little bit bigger. Guessing them is harder. If you could guess it, that's okay. If you could not guess it, you know, if you have watched the previous video, you know that you can do it in a systematic way without even guessing one number, yes? So, but this is not hard. So I need two numbers whose product is positive 85 and whose sum is negative 22. Yes. So that is minus 5 and minus 17. Yes. So I would write minus 5 and minus 17. Minus 5 added to minus 17 is indeed minus 22. And if you multiply minus 5 by minus 17, it becomes positive 85. Yes. So let us go to number 3. So number 3 is x squared plus 10x plus 16. Yes. So I open two pairs of brackets, put x here and there. Then I will ask myself, I need two numbers with whose sum is positive 10 and whose product is 16. And it's very easy, isn't it? So one of them is positive 2 and the other one is positive 8. Yes. The next one, I have x squared minus 4x minus 32. So I open two pairs of brackets, I put x here and there. I need two numbers with whose sum is minus 4 and whose product is minus 32. Yes. So one of them is negative 8, the other one is positive 4. Yes. So if I add minus 8 to 4, it becomes minus 4. And if I multiply them, it becomes minus 32. And let me solve problem 5 here. So I have x squared plus 20x plus 19. I did as before. So x here and x there. I need two numbers whose sum is 20 and whose product is 19. So it is easy, yes? It's 1 and 19. If I add 1 and 19, it becomes 20. And if I multiply them, it becomes 90. Yes? Okay, now let us go to problem number 6. So if you have watched the previous video, you know that I have introduced two different methods for you to solve these kinds of problems that you don't have a complete square. So here, the first term is not a complete square. So you cannot follow the same strategy that I used for solving the first 5 parts of the problem. Okay, so let me solve it and remind you again with two different methods, yes? So I would write method 1. So if you remember, one method is this. So I have 2x squared plus 3x plus 1. I multiply this expression by 2 and I divide it by 2. Yes, so it becomes 1 over 2. It becomes 4x squared plus 6x plus 2. Yes, so you see, I multiplied this by 2. It becomes 4x squared plus 6x plus 2. And then I divide it by 2. Yes, so this equality is indeed valid. But what is the benefit of doing this? Do you remember? Now I can imagine that this can be written as 2x to the 2 plus 3 times 2x plus 2. Yes. My goal is to give the role of the common term to 2x. Okay, so 2x to the power of 2. So 2x can play the role of the common term. If this is going to be the case, I should be able to see the common term in the middle term. Yes. So then what can I do? I can write 1 over 2. And now I open two pairs of brackets. I put 2x in each one of them. The 2x will play the role of the common term. And then I will ask myself, can I guess two numbers whose sum is positive 3 and whose product is positive 2? Yes, they are very easy. So one of them is positive 2 and the other one is positive 1. Yes, positive 2 plus positive 1 is positive 3, and 2 times 1 is indeed 2. So this is already in factorized form, but it is involved with this fraction. And I told you that whenever we want to factorize, by default, we want to factorize on the set of integers if possible. And here is of course possible, yes, because you immediately realize that I have a 2 in common, so I can take that 2 out. So then it becomes 1 over 2, and then I pull a 2 out from the first bracket, pair of brackets. It becomes x plus 1, and then I have 2x plus 1. And then immediately you realize that these 2 and that 2 are gone. So what is left is x plus 1 times 2x plus 1. So this is the factorized form of that expression. But if you remember, I also provided you with another method. So let me call it method 2. So this method is actually based on decomposing to middle term into the sum of 2 terms, okay, in an appropriate way. And I told you what can you do if you want to do it appropriately. So what should I do? So let me write this once more here. So I have 2x squared, 3x plus 1. Then I will ask myself that I need two numbers. I need two numbers whose sum is 3, which is this 3 here, and whose product is 2 times 1. The product is the product of this number multiplied by that number. So of course 2 times 1 is 2. Now can you guess those two numbers? So those numbers, the sum is 3, the product is 2, so one of them is 2, the other one is 1. Yes, so the numbers are 2 and 1, the numbers that we were able to guess. Yes. Then what should I do? I need to write the first term and split the middle term into a sum containing 1x and 2x. Yes, so what I mean is that I would write 2x plus x plus 1. Yes, so you see this 2 is this 2 here, and this 1 is this 1 here. So when I guessed these two numbers, when I was able to guess these two numbers, I will break the middle term, which is 3x in this case, into a sum of 2x and 1x, which is this one. And then I will take, for example, this one, and I will take 2x out. So the first one will be x, the second one would be 1. And then, of course, I can take x and 1 together. So then you will see that x plus 1 here and there is now a common term, so I can pull it out, yes? So what happens, it becomes x plus 1 times 2x plus 1. And that's, of course, the same answer as it should be, yes? So these are two different methods that I fully talked about them in my previous video, okay? So let us go to the next set of problems. Oh, sorry, there are still left. No, we are done, yes, yeah. So we go to number 7 on this page now. So you see these three are more or less the same. I need to follow the same strategy that I described in the previous page. So number 7. So I would write method 1, yes. So method 1, I would write it like this. I would write 5x squared minus 4x minus 1. And I told you that I need to multiply by 5 and divide by 5. So I would write 1 over 5, and I multiply every term by 5. So it becomes 25x squared minus 20x minus 5. Then I immediately realized that if this is going to be solved using this new identity, I have to give the role of the common term to 5x, yes? So it means that I would write 1 over 5, then I would write 5x to the power of 2. Instead of 20x, I write it in a way that I can see 5x in front of my eyes. So it becomes 4 times 5x, and then I have minus 5. And then I will give the role of the common term to 5x. So what I do, I would write 1 over 5, then I would put 5x here. I open 2 pairs of brackets, I put 5x here and inside each one of them, and then I will ask myself, I need 2 numbers with sum equal to minus 4 and with product equal to minus 5. So what are those numbers? One of them is minus 5 and the other one is positive 1, yes. So I would write minus 5 here and positive 1 there. If I add them, it becomes minus 4, and if I multiply them, it becomes minus 5. And now I can pull out a 5 from the first pairs of brackets, so it becomes x minus 1, and then I will have 5x plus 1. And then this 5 and 1 over 5 are simplified, so I will get x minus 1, 5x plus 1. Okay, so that was method 1. For this one, I can use method 2 to solve the problem. In this method, what I do, so let me write this here, 5x squared minus 4x minus 1. Then what I can do, I can ask myself, I need 2 numbers with the sum minus 4, and the product is 5 times minus 1, yes? So it becomes 5 times minus 1, which is minus 5. And now I ask myself, can I guess 2 numbers whose sum is negative 4 and his product is negative 5? Then it becomes clear that those numbers are minus 5 and 1. Yes, so one of the numbers is minus 5, the other one is positive 1. But now my interpretation is a little bit different here. What I need to do, I need to break this middle term, minus 4x, into a sum. One of them is minus 5x, the other one is positive x. So what I need to do, I need to write 5x squared instead of minus 4x, I write minus 5x, and then I would write plus 1x, which I can simply write x, and then I have minus 1. Then you can immediately realize that you can factor 5x from these 2 terms, okay? So it becomes 5x, x minus 1 is left, and then I have x minus 1. And of course, then you see that x minus 1 becomes the new common factor, so I can take it out. And then you see that, sorry, it becomes positive 1. So this sign is positive. Okay, so this is the same answer. Okay. So, number 8. So, method 1. So, what can I do? Let me write it. Minus 6x squared plus 5x plus 1. I will do the same, but this time I have to multiply by minus 6, and I have to divide by minus 6. So it becomes minus 1 over 6. If I multiply everything by minus 6, it becomes 36 x squared minus 30x minus 6. Yes? And now you know that I am going to give the role of the common term to 6x. So I would write it as 6x to power 2. I need to write in minus 30 in a way that I can see 6x in front of my eyes. So it becomes minus 6x, and then I multiply it by 5, yes? So minus 30x is minus 5 times 6x, but the good point about writing it in this way is that I can see the common factor in front of my eyes, yes? And then I will have minus 6. And then, as usual, I would write over 6, and I open 2 pairs of brackets, 6x here, 6x there. Then I ask myself, I need 2 numbers with minus 5 as the sum, as minus 6 as the product. So it is minus 6 and positive 1. Yes, so I would write minus 6 and positive 1. Then what can I do? I can factor minus 6 out from this one, so it becomes minus 1 over 6. If I factor minus 6 out, it becomes 1 minus x, and then I have 6x plus 1. Then this one and that one are cancelled. This negative sign and that negative sign are also cancelled, so I will get 1 minus x, 6x plus 1. And that is the factorization of this polynomial using method number 1. Okay, so now we can also solve this problem using method 2. So here, what I need to do is, let me write it once more. So it's minus 6x squared plus 5x plus 1. Then I will ask myself, I need two numbers whose sum is positive 5 and the product is minus 6 times 1, which is minus 6. Then I think it's very easy. You see that actually we did it before. What are those two numbers? The numbers are so it's 6 and minus 1, yes? If I add 6 and minus 1, it is positive 5. If I multiply them, it becomes negative 6. Then I will use these two numbers to break the middle term. So it becomes minus 6x squared. Instead of 5x, I put 6x minus x, and then I have plus 1. Then between these two, I can factor a 6x out. So if I factor 6x out, 1 minus x is left from the first one. And then the other one is minus x plus 1, which can be written as 1 minus x. Then I can factor 1 minus x out. It is 6x plus 1 left. Yes, so that's also a solution to this problem. And here it's 15 minus a minus 2a squared. Yes. So let me write 9. The question is 15. Let me see it once more. 15 minus a minus 2a squared. Okay, so what can I write? First, I arrange the terms, minus 2a squared minus a positive 15, yes? So if you want, we can just do it in two methods again. So method 1. So what I do is to multiply everything by minus 2 and then divide by negative 2 as well. So this minus 2a squared minus a plus 15 is equal to minus 1 over 2 multiplied by, I multiply everything by negative 2, it becomes 4a squared plus 2a minus 30. And then I will give the role of the common term to 2a by writing it in this way. But this is already in 2a form. So what does it mean? This means that this number is indeed 1. And then I have minus 30. Then what I do, I open two pairs of brackets. I will give the role of the common term to 2a. Then I will ask myself, I need two numbers with plus 1 as the sum and negative 30 as the product. So what are those numbers? One of them is positive 6 and negative 5. Yes, so it becomes positive 6 and negative 5. And then you can write it as minus 1 over 2. I can factor 2 out. It becomes a plus 3, and then I have 2a minus 5. But these 2 and that 2 are cancelled, so you can write minus a plus 3, and then I have 2a minus 5. Of course, that's completely okay if you want to keep it in this way, but myself prefer to multiply this negative sign into this bracket, and then I would write it as a plus 3, and then I will have 5 minus 2a. Yes, so this is for me, I like it to write it in this form. Otherwise, this is also correct. Okay, so let us go to method 2. So method 2, what should I do in method 2? So let me write it in this order. So it's minus 2a squared minus a plus 15. Then I will ask myself that I need two numbers whose sum is -1, the coefficient of the middle one is -1, and the product P is minus 2 times 15, which is minus 30. And then what are those numbers? The numbers are exactly as before. So I have minus 6 and positive 5. Those are my numbers. So what I do now is to break the middle term into minus 6a plus 5a, and then I have 15. Yeah, so you see that I have minus 6a plus 5a. It will give me negatives a. Everything is actually correct, so these two are indeed equal. But now, if I take these two and factor 2a out, negative 2a out is better. So then a is left from the first term, positive 3 is left from the second one. And between these two, I can factor a 5 out, so it becomes 5 times a plus 3. You see, immediately I get this factor in common, so I can pull it out. So when I pull it out, it becomes a plus 3 minus 2a is left from the first one, and 5 is left from the other one. But of course, you can immediately realize that I can write it as a plus 3. Instead of writing minus 2a plus 5, I can write 5 minus 2a, which is exactly the previous answer as it should be. Okay? Okay, now let us go to the next problems. So number 10, we want to factorize this polynomial. Here we have this polynomial. I hope that you can immediately see that even though this is not technically a trinomial, but it is written in a way that we can consider it to be a trinomial if we consider this as to be the common term, yes? So let me write it in this way. So 10, I would write it in this form. I would realize that x to the 4 minus 1 will play the role of the common term for me. So I will open two pairs of brackets, and then I would put x4 minus 1 here and here. Oh, sorry, x4 minus 1, giving the role of the common term to x4 minus 1. Then I will ask myself, I need two numbers whose sum is minus 18 and the product is positive 45. So if I start, for example, from 45, 45 can be written as a product of 1 and 45, but 1 and 45, the sum of them will not give me 18 or minus 18. But I will have 3 and 15. 3 and 15 will, the product which becomes 45, the sum of 3 and 15 becomes 18, then I can adjust the signs, yes? So the numbers are actually quite good. So I will have 3 here, I will have 3 here, and then I will have 15 here. But the sign, because the product is supposed to be positive, either both of them are positive or both of them are negative, but because the sum is supposed to be negative, both of them has to be negative. Okay, so that's already in the product form, but we never leave it like that. We can simplify this. So this becomes equal to, so here x4 minus 1, we don't need these extra brackets. So minus 1 and minus 3 becomes minus 4. So it becomes x to the 4 minus 4. And then here we have minus 1 and minus 15. It becomes minus 16. So it becomes x4 minus 16. Even though this is already in product form, but the factorization is not complete yet, because hopefully you can realize that both of them are actually revealing the conjugate pattern. So I would write the first one, I would write it as x squared minus 2 times x squared plus 2. But for the second one, I can write x to the squared minus 4 times x squared plus 4. Yes. here I will not continue more, because if I want to continue more, I can of course write x to the 2 minus 2 is equal to x minus square root of 2 times x plus square root of 2. That's completely valid. But I told you that by default, we want to continue the factorization. And we only, by default, we want to factorize on the set of integers. So even though this is also valid, but this involves square root of 2, but the square root of 2 is not an integer. So if explicitly they ask for us to go to factorize on the real numbers, then we continue. Otherwise, we will not do this. So let me clean this. So this cannot be factorized more. 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 If you want to factorize this, you need to use complex numbers. But this one still can be factorized using the conjugate pattern once more. So what I would write x squared minus 2, x squared plus 2, the first two terms. I just copied and pasted. But the third term can be factorized into x minus 2 times x plus 2. And then I will have x squared plus 4 at the end. Yes, so yeah, that's the factorization of this polynomial. So number 11. So I have 4x squared, and then I have plus 8xy minus 45y squared. Yes. So what can I do here? I can write the first term as 2x to the 2. Then I want to give the role of the common term to 2x. So I need to write the middle term in a way that I can see 2x in front of my eyes. So instead of 8xy, I can write 2x, and then I will multiply it by 4y. So 4y times 2x is actually 8xy. And then I would write minus 45y squared. Okay, so if this is going to be used to be solved using the common term identity, 2x will play the role of the common term. So I open two pairs of brackets, put 2x in each one of them, and I ask myself, I cannot say I need two numbers whose sum is 4y, because if I have numbers, if I add them, it becomes a number. It cannot become 4y. So I need two expressions whose sum is 4y, and the product is actually minus 45 y squared. Yes. So then, I don't know, it's not that hard to guess. If you just think about numbers 4 and minus 45, so I need two numbers whose product is minus 45 and the sum is 5. So one of them is negative 5, the other one is, so one of them is negative 5 and the other one, negative 9 and the other one is 5, yes. If I, no, sorry, the other way around, positive 9 and negative 5. If I add them, the sum becomes 4. If I multiply them, the product becomes negative 45. But now I need expressions whose sum is equal to 4y, and the product is minus 45y squared. So it's clear that it should be positive 9y and negative 5y. So I put positive 9y and negative 5y here, yes? So you see the common term to the power of 2, the sum of these two terms, which becomes 4y, multiplied by the common term, and the product of these, which becomes minus 45y squared. So that's the factorization of this polynomial. Okay, so you see, if you compare this one with this one, they are similar, but the point is that this 2x squared is not a common, is not a complete square. So what I need to do, I can solve it in two different ways again. So let me just do them, yes, one by one. So let me write method 1, for example. So number 12. Here we can use method 1 to solve this problem. So 2x squared minus 17xy plus 20y squared. Yes, what can I do? I can multiply it by 2 and then divide it by 2. So I will write 1 over 2, 4x squared minus 34xy, and then I will have 42y squared. Yes. And then I want to give the role of the common term to 2x. So I would write it as 1 over 2, 2x to the 2. Then I would write 2x in a way that I can see it here, but I have minus 34. So I will multiply it by 17y. And then I will have 42y squared. Yes. So then I would write 1 over 2. I open 2 pairs of brackets, put the 2x in each one of them. I want to give the role of the common term to 2x. Then I will ask myself, I need 2 expressions with sum equal to minus 17y and with product equals to 42y squared. But none from this experience you have here, you don't need to be bothered because of these y and y squared. What you need to ask yourself, I need 2 numbers whose sum is negative 17 and product is 42. So one of them is negative 3, one of them is negative 14, yes. So I would write negative 3 and negative 14. But here I need to have, the sum should be negative 17y. So I put a y here and a pi and a y there, yes. So now I hope that you can convince yourself that the sum of the sum of minus 3y and minus 14y is indeed minus 17y. And if I multiply them, minus 3 times minus 14 is positive 42. And then y times y is y squared. So what I have written here is completely correct. And then, of course, I can factor a 2 out from the second brackets. So it becomes 2x minus 7y. Then what happens is that this one and that one are gone. So what you get is 2x minus 3y, and then I have x minus 7y. Yes. So method 2, in method 2, if you remember, so let me write this down again. So I will have 2x squared minus 17xy plus 20y squared. Then I will ask myself, okay? And so before doing that, here in this, I need to write it in this way first. Minus 17y times x, and then I will have 20y squared, yes? Then I will ask, I need 2 expressions whose sum is negative 17y and the product is 21y squared, yes? So hopefully you can guess them. That's exactly the same problem as we did in method 1. So what are they? So one of them is minus 3y and the other one is minus 14y, yes? But then I use this educated guess to break the middle term, and I will write it as 2x squared. Instead of 17xy, I would write minus 3xy, and then I would write minus 14xy plus 21y squared. Okay, then what can I do? I can take these two together and pull x out. So this becomes equal to x, 2x minus 3y. And then here I can take these two and pull negative 7y out, yes? So what is left from the first one is 2x, and what is left from the second one is exactly minus 3y that I need. Now you see that this becomes a common term, so I can take it out. So it becomes 2x minus 3y, and then I have x minus 7y. Yes, so this is another way to come to that answer. Okay, so The other problems here, problem number 13. Okay, so if you see problem number 13 is one of those problems that I cannot do it in my head, okay? The numbers are big, so I put my calculator in front of me so I can use the calculator of my iPhone here. So yes, hopefully I can use it. Okay, so do you remember what was the rule? So if I want to factorize a polynomial, a quadratic polynomial like this, so just let me remind you from the previous lecture, you can write it as a times x minus x1 times x minus x2, where x1 and x2 are the roots of the equation ax squared plus bx plus c equal to 0. So yes, I have discussed about this method, the proof of this method, and everything's uh, related to this problem in the previous video, but that was the uh, result that we got, okay? But the good point about this method is that it's completely systematic. I really don't need to be able to guess the numbers with a given sum and with a given product. I cannot do them here. You see, this is, I need to, if I want to guess, I need to guess two numbers whose sum is 80 and whose product is the product of these two numbers. It might be possible for some of us, but it is not that easy for me as well, at least. So what I can do, I can rely on this, and what I do, I will try to solve this problem. So let me do this. I would write this 77x squared plus 80x minus 170, and I put it equal to 0 because my goal is to find x1 and x2. So, so for this, I calculate delta. Delta is b squared minus 4ac. So it is 80 to the power of 2 minus 4 times 77 times minus 170. So the first number becomes 6,400. And the next one, let me calculate using my calculator. So 4 times 77 times 117 is equal to this number. And then I have two negative signs, so it becomes positive. And if I add 6,400 to it, so sorry, it's 36 plus 6,400 is 42,436. Yes. Okay. Now x becomes negative b plus and minus square root of delta divided by 2a, but negative b is negative 80 plus and minus square root of this number divided by 2 times a, which is 154. But I use the calculator to calculate this square root sign. It becomes the square root, to calculate this square root, it becomes 206 divided by 154. Yes. So now, if I want to solve the, if I want to solve the problem, it becomes x is equal to minus 80 minus 206, which becomes minus 286 divided by 154. And the other one is 126 divided by 154. Yes. So at least here I can divide by 2, so it becomes 77, and then this becomes 143. and then I can simplify by 11, it becomes 7, and then this becomes 13, yes, yes. So the first number is this one here. If I divide by 2, it becomes 63 and 77. Then I divide by 7, it becomes 9/11. Yes, so I have these two numbers. So let me call this one, for example, x1, and let me call this one x2. So you see, I am using my calculator to calculate things, not guessing things at all. And then now I use this, I would write 77 x squared plus 80x minus 117 is equal to, according to this formula, I have to write a in this case is 77. So I would write 77, x minus x1, but x1 is negative, so it becomes negative, negative means positive, yes, and then x minus x2, which is 9/11. But of course, this is in factorized form, but it has been factorized not in the set of integers, but in the set of rational numbers. And I told you that by default, if possible, we want to factorize it in the set of integers. But that's not an obstacle here, because instead of 77, I can write 7 times 11, and then I would write x plus 13/7 times x minus 9/11. So here, for example, to get rid of this 7, I choose to multiply 7 here, and to get rid of this 11, I choose to multiply 11 in this bracket, okay? So what happens is, if I multiply 7 in the first brackets, it becomes 7x plus 13, and the next one becomes 11x minus 9. So that is the factorization of this polynomial. Okay, so number 14, so let me bring this down with me here. So this is number 14. It doesn't work in that way. So let me write x squared plus 2x plus y. So number 14. X squared plus 2xy plus y squared minus 2x minus 2y minus 3. So if I want to factorize this, of course, I think this is easy to see that the first 3 is actually a quadratic pattern, yes? So I can write it as x plus y to the 2. And then between these two, I can factor a minus 2 out. So it becomes x plus y. And then I am left with minus 3 at the end. Okay? But then it's clear that this is, even though technically it's not a trinomial, but this is written in the form of a trinomial. And then we realize that it would be a good idea if I can give the role of the common term to x plus y here. Yes. So what I do, I can write it in this form. So it becomes x plus y. I open 2 pairs of brackets, x plus y in each one of them. And then I will ask myself, I need 2 numbers whose sum is minus 2 and the product is minus 3. Yes. So those numbers are minus 3 and positive 1. So I put minus 3 in one of them and positive 1 in the other one. Okay, so that was easy. But the last one here is a little bit technical here, and I have extensively talked about this factorization in my previous video, but I will probably repeat a little bit around that even in this case. So, but I need to write this 3x squared minus 11x. So let me write 3x squared minus 11xy, and then I have plus 6y squared plus 7x minus 7y plus 2. Yes, so this is problem number 14. Sorry, number 15. So let me double check once more. 3x squared minus 11, yes. Yes, that's correct. Yeah. So if you remember, I told you the trick about factorizing these type of second degree polynomials. Yes. So I write this as a polynomial in terms of x, a second degree polynomial in terms of x. So I would write 3x squared, then I will have an x term here and x term here. So I factor x out. So what is left for me is I will have 7 minus 11y times x. So what I did, I factored x from these two terms. Yes. And then this term, and this term don't have any, none of them has any x term. So I will write them separately. So then it becomes 6y squared minus 7y plus 2. Yes. Then I use the same recipe here. So I want to use this formula again. But of course, my coefficients A, B, and C are no longer numbers. They are expressions. Okay. So here, of course, A is a number, but B is this and C is this. Okay, but I can use the same recipe again. So what I do, I write delta is equal to B squared minus 4AC, but this is my B now. So then it becomes 7 minus 11y to the 2 minus 4 times a, which is 3, times 6y squared minus 7y plus 2. Yes. We have to simplify this a little bit. So let me raise the first one to the 2. So it becomes 49. 2 times the first one times the second one. 2 times 7 is 14. And then it becomes 154, yes? So minus 154y, and then the second one to the power of 2 is 121y squared. And then I have minus 4 times 3, which is 12. And then I multiply it inside, it becomes negative 72y squared plus 84y. And then I will have minus 24, yes, minus 24. So if I simplify this, this one minus this one will give me 49y squared, yes, and then minus 154 and positive 84 will give me negative 70. So it becomes negative 70y. And then finally, 49 minus 24 will give me positive 25. Okay, but then you see a trinomial, and you see that you have two complete squares. So you get suspicious that it might be a quadratic pattern. How can I check that this is indeed the case? Do you remember? I go to a scratch paper. I take the square root of the first one, it becomes 7y. I take the square root of the last one, which becomes 5. Then myself multiply by an extra 2. So this becomes exactly 70y, which is the middle term. So that's a complete square indeed, okay? So let me clean this scratch paper here. And then I will get 7y minus 5 to the 2. So actually, this is delta. And then I want to find the x values, not values, the expressions for x1 and x2. So let me just write x. X is minus b plus and minus a square root of delta divided by 2a. What is my b? This is my b. So when I multiply it by a negative sign, it becomes 11y minus 7. And then I have plus and minus a square root of 7y minus 5 to the 2, and then I will have 2a. Yes. But the square root of this, it's simple. Yes, it becomes a minus 7 plus and minus. The square root of this expression to the 2 gives me 7y minus 5, but I need to put brackets around it. Sorry, this is not 2a. What was my a? My a was just 3, so I multiply by 3. This is my a, yes. So then it becomes 6. Then I will have 2 roots, yes. So let me write it. So x1 becomes equal to 11y minus 7. Let me keep the positive sign first. Minus 5 divided by 6. Then what happens? 11y and 7y becomes 18y. 18y. And then minus 7 minus 5 is minus 12 divided by 6. So I can divide by 6. It becomes 3y minus 2. Or you can factor 6 out and simplify. And x2, I need to take the negative sign. So it becomes 11y minus 7 minus 7y positive 5 divided by 6. So it becomes 4y minus 2 divided by 6. I factor a 2 out. So it becomes 2y minus 1 divided by 3. Yes? So what should I write? The expression is equal to, so you see, the expression here is a times x minus the first root, x minus the second one. A in this problem is 3, so then it becomes 3 times x minus the first one times x minus the second one. Okay, but I can, here, I can open these brackets, so it becomes x minus 3y plus 2, and I will multiply this y in the second one, in the second brackets, so it becomes 3x minus 2y minus minus y is plus y. So that is the factorized form of this polynomial. Yes? Okay. Now let us go immediately to the next problem. So this problem is asking you to solve this equation. So this is not related to the previous lecture. From the previous set of problems, I have decided to split the problem set into 2 parts. One part which is directly related to the lecture covered in that session, and the other one is related to the previous lectures. The reason that I did this because I want to make sure that you will not forget what you have learned in the previous lectures. So usually these questions are related to the previous lectures. Okay, here I'm supposed to solve this equation. So it means that I need to find the appropriate value for x so that this equality is satisfied. And then I have provided you a hint that, okay, you can give 5x another name, call it a, and then 7x to be called b. Okay, then what happens? So it means that I can rewrite this equation in a way that only a and b are involved. Okay, so what can I do? Okay, so this part I don't have any problem with. It's exactly a. This part I don't have any problem with. This is b. So if I probably want to succeed to solve this problem, I have to write all these 3 terms in terms of a and or b, yes? So what can I do? For example, because 5x is supposed to be a, so you see that if I raise both sides to power 2, yes, something like this, then you see that I can write it as 5 to the power of 2x equals to a to the 2, yes, because these exponents will be multiplied together. But then you can immediately realize that I can write it as 5 to the power of 2 to the power of x is equal to a squared. Because again, 2 times x is the same thing. But then 5 to the 2 is just 25. So then it becomes 25. This implies that 25 to the x is a squared. Yes. I think the idea behind 49 to the x is now clear. It's very clear. So what is that? So the same idea, yes? So I would say that 7 to the power of x, we took it to be b. I raised both sides to power 2 again. But for the same reason, this becomes 49x is equal to b squared. So that's also good. And then 35x, what can I write for 35 to the power of x? Instead of 35, I can write 5 times 7 to the power of x, but this can be written as 5 to the x times 7 to the x. But I gave 5 to the x another name to be a, and 7 to the x another name to be b. So what happens, it becomes a times b. Okay? So now everything is clear. So let me write it in this way. 35x, so this is a, this is b. So 35 to the x is a times b. So then instead of, so I rewrite this equation, but I would put a for this, b for this, a to the power of 2 for this, b to the power of 2 for this, and ab for this. Yes. So then it becomes a plus b minus a squared plus ab minus b squared is equal to 1. Yes? And then hopefully you know what to do here. You have enough experience from previous lectures. Okay, so what can I do? I can write it in this form. I can move a squared and b squared to the right, so it becomes positive a squared, positive b squared, and then I have positive 1. And then what is left on the left-hand side for me is a plus b plus ab, yes? So then you realize that you can write it in this way. You can say a squared plus b squared plus 1 to the 2. Instead of 1, I can write 1 to the 2. Instead of a, I can write 1a times 1. Instead of b, I can write b times 1. And instead of ab, I just simply write ab. And let me remind you of a theorem that we had before. So if box to the 2 plus circle to the 2 plus triangle to the 2 is this combination, yes? Do you remember we could conclude by method of completing squares, and the sum of squares cannot be 0 unless each one of them is individually equal to 0. We were able to prove this theorem that if this happens, then the contents, what is contained by these containers, box, circle, and triangle, has to be exactly the same. So here, if you give the role of box to A, and if you give the role of circle to B and triangle to 1, then you realize this becomes exactly box to the 2, circle to the 2, triangle to the 2. On the right-hand side, A times 1 is box times triangle, B times 1 is circle times triangle, and A times B is box circle. So that is exactly the same pattern. So it means that what has to be done is that A is equal to B, triangle is equal to box, the box is equal to the circle is equal to the triangle, yes? So it means that A is equal to B is equal to 1, yes? Okay. So then A is equal to 1. What happens? A is equal to 1, so then
a is equal to 5 to the power of x, so 5 to the power of x is 1. And b is also equal to 1, but what is the name of b? B was 7 to the power of x. Then 7 to the power of x is also equal to 1. But if 5 to the power of x is equal to 1, it means that x is equal to 0. There is no other value for x. And then, fortunately, this x equal to 0 also satisfies this equation. So the answer, the solution to this is just simply x equal to 0. Okay? Good. And then let us go to the next problem. So the next problem is this. Let x, y, and z be, let x, y, and z and w be rational numbers such that the sum of these numbers is equal to 0. We're supposed to prove that this expression is a rational number. Okay, so you see, x, y, z, and w are already said to be rational, and we want to prove that this expression is rational. Okay, because x, y, z, and w are rational numbers, so it means that this expression is rational. This expression is also rational. This expression is also rational. So if I multiply them, it is rational. But the problem is that when I take a square root of a rational number, it's not guaranteed automatically that the expression itself becomes a rational number. For example, 2 is a rational number, but when I take square root of 2, it becomes square root of 2, which is probably the most famous irrational number. So if I want to prove this problem, somehow I need to use this information to prove that what is below this square root sign is indeed a complete square. Yes? So that is I want to show. Instead of working with the whole expression, I will only work with this under the square root sign and then try to motivate and prove that this is indeed a complete square. And what I want to use in here is one of those identities that I told you before. So if I have, for example, a plus b plus c plus d to the 2, we talked in the last session of related to algebraic identities about some extensions of some of the identities. One of those identities that I talked about, its extension, was this identity, that if I have a plus b plus c plus d to the 2, the answer becomes the first one to the 2, the second one to the 2, the third one to the 2, and the last one to the 2, plus 2 times the first one times the second one, the first one times the third one, and then that was the identity, yes. Yes, that was the identity. So I want to use this identity here. But before doing that, let me try to expand this expression, okay, on the expression under the square root sign. So xy minus zw, yz minus wx, and then I have zx minus wy. Yes, so what should I do? So let me multiply the first two brackets and then find the answer, and then multiply the result by the last one. Okay, so let us do that. So the first two brackets here, this term multiplied here, this term multiplied there, this term multiplied here, and etc. Yes. So then it becomes x y squared z minus x squared y w minus y z squared w, and then I have plus x z w squared. Yes, and then I have zx minus y w. Yes, I need to multiply once more, but I will have 8 terms involved, so we have to be patient and careful not to make mistakes. Okay, so the first term I will take this first term, multiply it here and there, and then I will go to the next term, multiply it here and there, and then continue. So it becomes x squared, it becomes x squared, y squared, z squared, minus x, y to the 3, z w. I will go to the next one. So it becomes minus x to the 3, y, z, w, plus x squared, y squared, w squared. Then I go to the next one, minus x, y, z cubed, w, plus y squared, z squared, w squared. And then I will go to next one, x squared, z squared, w squared, minus x, y, z, w cubed. Yes. I have 4 complete squares here. I write them together, and then I will have this term, this term, this term, and this term. All of them share in the factor x, y, z, w. So when I pull it out, yes. So what I am doing is I am writing it as x squared, y squared, z squared, plus x squared, y squared, w squared, plus y squared, z squared, w squared, x squared, z squared, w squared. Then I have minus x, y, z, w. I pull this out from all the terms left. So here, you see I have here, so x squared is left from this one, y squared is left from this one, and then z squared is left from this, and finally w squared is left from this. So I will get x squared plus y squared plus z squared plus w squared, yes? Okay. But what can I do? Using the same identity here, you see, if I have the sum of 4 complete squares, I can write it the sum of all of them to the power of 2 minus 2 times of this combination. Yes? So what I'm saying, let me repeat. I have the sum of 4 complete squares. What can I do? I can write this is equal to this expression minus the whole expression, yes, because I move this to the left-hand side. Now, I will give the role of A to X, Y, and Z. I will give the role of B to X, Y, and W. I will give the role of C to Y, Z, and W. And finally, I will give the role of D to this expression. And I will use this rule, yes? So what can I do here? So let me put this in the box here. So this becomes equal. Instead of these first 4 terms by these substitutions, I can write this. I can write xyz plus xyw plus yzw plus xzw to the power of 2. But minus, so you see, the sum of complete squares, the sum of 4 complete squares is equal to the sum of all of them to the power of 2 minus 2 times the first one times the second one, the first one times the third one, etc., etc. So here, what can I write? Instead of these 4 terms, I can write the sum of all of them to the 2 minus 2 times the product of A and B, which becomes x squared, y squared, zw. Then the product of A and C, so it becomes x, y squared, z squared, w. The product of A and D, x, y, x squared, y, z squared, w. Then the product of B and C, which is x, y squared, z, w squared. The product of B and D, which is x, x squared, y, z, w squared. And finally, the product of C and D, which is x, y, z squared, w squared. Okay, so what I have written here is equal to only these four terms. Yes. And then I will write the rest of it. The rest of it is this one. So then it becomes minus x, y, z, x squared plus y squared plus z squared plus w squared. Yes. Okay. So let us see now how it goes. It becomes equal to, so let me copy and paste the first term, xyw, yzw plus xzw to the 2. Then here, in all of them, I can take xyzw out. Yes, so it becomes minus 2xyzw. And then what is left from here? What is left is x times y. And the next one is y times z. The next one is xz, yw, and then xw, and xzw. Yes. And then I will have minus xyz, x squared plus y squared plus z squared plus w squared. Okay. But now, what can I write instead of this expression? So here, instead of this expression, I can again write x plus y plus z plus w to the 2 minus 2 times xy, xz, xw, yz, yw, and zw. Yes, I am using the same identity once more, but I have replaced A with X, B with Y, C with Z, and D with W. Okay, but now look, here X plus Y plus Z plus W is supposed to be equal to 0. So what can I do? This term actually vanishes. So let me just cross it over. This is indeed 0. And then I have minus, so I should have made a mistake somewhere. Yes. So you see, I forgot to write a W here. There is a W here as well. So this was W involved. So I forgot to write a W here. So there is also a W here. Okay. So now what is left for me? If I multiply, so this is 0, then I will have minus 2 times this combination multiplied by negative this, it becomes positive 2, yes? So this becomes equal to positive 2 x, y, z, w, xy plus xz plus xw plus yz, yw, and zw, yes? So what I'm trying to say is that this expression is equal to positive 2 times this expression. But this is negative of the same expression. So this and that will be canceled. So what I will get is that this is indeed equal to a complete square. Yes. So what I did is that I started this, I started expanding this product, and then I used this identity 3 times, and then I was able to show that that expression becomes equal to this. But this is it's a complete square. So then it means that if I take the square root of this expression, it becomes this expression without this 2. And what is left is just this one for me, which is a rational number because x, y, z, and w are supposed to be rational numbers. Okay?
Okay, thank you for watching the video. I hope that this video was somehow useful in explaining the solutions of those problems. Okay, until the next video, take care and goodbye.